event. Despite being the speaker immediately after the launch, everyone is lazy. But we are trying to fill this room with energy. Energy is the main player of the world economics and politics now. For the energy, we are here in this room today. So our presentation would be energy efficiency and sustainability. It's a flare recovery case study. So the presentation objectives will be like this. These very simple series of questions. Why are we flare? I don't have the points. Sorry. So yes. So why do we have to cut this flare? And what is the flare? And a case study, and finally we will have the summary. So believe it or not, 1 in each 5 death cases across the globe is due to fossil fuel air pollution, according to a study that took place in September 2021. For the same reason, 6.5 million human beings are losing their lives every single day, according to a study that took place on May 2022 by Lancet Planetary. So now you will be asking me, what can we do, right? In 2021 as well, 144 million cubic meters of natural gas has been needlessly, without any necessity, burned in the oil and gas upstream facilities, resulting in 400 million tons of equivalent CO2, scope 1 direct emissions according to the sustainability ESG measurement methods. Again, we come back to the question you were asking me, what can we do? Well, if we go to or refer to Mr. Stephen Covey's most and everlasting book, The 7 Habits of Highly Effective People, we as a human beings have been awarded the gift of a choice. So instead of asking ourselves powerlessly and reactively, what can we do? We are losing our influence circle, and our influence circle now is shrinking. But if we have the quote of Mr. Einstein, if I'm having a problem, to solve it, 1 hour to solve it, I'll be spending 55 minutes thinking of the problem itself, identifying it, and only 5 minutes thinking of the solution. So now we will turn our attitude, our paradigm to be powerful one, proactive one, allowing ourselves, allowing the influence circle to enlarge, to vice versa. Instead of shrinking our influence, we will shrink the concerned one. We will now define the flare itself. So what is the flare? The flare, according to the ABI, is a safe disposal of the useless relieved gases or liquids. And according to the CABV Canadians, it's the controlled burning of the useless natural gas due to its insufficiency or efficiency regarding the cost and the technical knowledge. So it's a safe disposal or the controlled burning. So how would you control the burning, or how would you dispose this useless natural gas unless you're having a necessity, unless you're having a need to control this burning? So accepting the fact to be a part of an EBC mega project contractor who's being awarded projects from Iraq up to Algeria, we in Petrojet staff always seek new opportunities, enhance new solutions serving our nation and all humanity. So I will take you up to a case study in the Western Desert where we had a 4 million standard cubic feet per day used to be flared without any necessity, losing a power of approximately 5.5 megawatts. And what's more important and dangerous is emitting a direct CO2 scope 1 of more than 22,000 pounds per hour. At the same site, we are having a gas compression station which is consuming from the national grid 5.1 megawatts. And as scope 2 indirect emissions, we are having more than 4,000 pounds per hour of CO2. So in combination, we are losing or wasting a power of 10.6 megawatts, and also we are emitting in combination scope 1 and scope 2 more than 27 pounds per hour of CO2. And going to the cost of this power approximately 23.2 every single day, and the cost of the flaring itself is 5,000, wasting power, and what's most dangerous is harming our environment, as you see. So we have to come up with some kind of solution, as we have presented in the first of our presentation, that we have to be proactive. So we came up with something which will turn this flared gas to serve this gas compression station. It's a gas to power skid. It's a very simple one. The main components of it is a gas filtration, gas metering totalizer, a water bath heaters, and gas reduction, and outlet scrubbers and the E&I work. These are the design conditions: the 42 bar gauges design pressure, 70 Celsius design temperature, and a capacity of 4 million standard cubic feet per day of gas. Its length, 8 meters of length, 2.2 meters of width, and 300 millimeters of height, 6.5 tons of weight. The process simulation, which I've crafted with my own hands, I would like to share it with you. It has been done by the UNICEF software, by the way. This is the filtration, as you see, and this is the water bath heaters, and these are the oil scrubbers, and then producing the gas exactly on the required specifications by the gas compression stations. If you see, you are having a water dew point of approximately -15, and a hydrocarbon dew point the same, more than -15 Celsius. The water bath heaters are consuming each one 0.06 megawatts, and the saved power is approximately 5.09 megawatts. So we have saved 4 million standard cubic feet per day of gas, which used to be burned. We also have saved $1.1 million every single year. What's most important, we have cut the emissions of more than 27,000 pounds per hour. So in summary, we had a case study. 4 million standard cubic feet per day of gas used to be burned in the site needlessly, losing a power of 5.5 megawatts. At the same site, on the other side, we have a need, a necessity to consume power of 5.1 megawatts, which indirect scope 2 of indirect emissions, we had more than 4,000 pounds per hour of CO2 emitted to the environment. In combination, scope 1 and scope 2, we have more than 27,000 pounds per hour emitted to the environment, wasting a power of 10.6 megawatts, and losing a money of $1.1 million every single year. So providing our solution, we have got this 4 million stands, saved them. We have saved the consumed power of 5.1, and also saved the wasted power of 5.5 megawatts, with a capex of only $1 or $1.1 million. We have saved this bleeding of money. So we have saved the cost. It's useless now. Thank you so much. We have saved the money.
It's okay, enjoy it, Mohamed, enjoy it.
Enjoy it, yeah, a few minutes.
Yeah. We have saved the money, we have saved power, and what's more important, we have saved our environment for ourselves and all humanity. I would like to acknowledge the support of His Excellency, Jean Tariq Al-Moula, the Egyptian Minister of Petroleum Resources, and also the support of everyone in Petrojet, especially His Excellency, Jean Walid Lutfi, the Chairman, all my colleagues, managers, and clients and cooperative vendors, and thank you so much for this presentation. It's been my own time. If anyone have questions, you are so welcome.